Hello everyone, welcome back to the channel. In today's video, we are going to explore a super useful concept in software project management, function point analysis or FPA. If you are someone working on academic projects, preparing for presentation or just trying to understand how software estimation works, this one for you. This presentation we are covering is by Aman Yewale from MCA FI Division A, the student of Vishwakarma University, and today we will break it down slide by slide, explaining everything in details. By the end, you will not only understand function point analysis, you will be ready to apply it in real scenarios. So let's get started. So here is the opening slide. Function point analysis is a technique used to measure the functional size of a software application. But what does that really mean? Instead of measuring things like lines of code, FPA focuses on what the software does for the user, its function, so it's more accurate reflection of user's perspective. FPA is particularly useful in large-scale complex software projects where functionality is a critical driver of a project efforts. Its structured approach ensures transparency and consistency in project planning and execution. Now let's properly define it. Functional point analysis is a standardized method developed by IBM in the late 1970s. It is used to measure software size by qualifying the functions the systems provide to the user. This method helps with estimating cost, predicting timeliness, comparing productivity across different teams. What school is? It's independent of the programming language. So whether you are building in Java, Python or even low code platform, the estimation logic remains the same. It's especially useful during the early stages of software development when you don't have a single line of code but you need to make time or budget decision. Now let's talk about some key features of FPA. Technology agnostic. It doesn't rely on source code, so it's perfect for comparing projects across technologies. User-centric. It reflects the user's experience by focusing on inputs, outputs and data usage. Quantifiable. It gives numbers you can track, total function points, weight, values and complexity scores. Repeatable and objective. When done properly, FPA provides consistent results across different analyses. This is why FPA is often used in industries like banking and insurance, where estimation accuracy can directly affect cost saving. Moving into the process, the first step is to identify the scope. You need to understand what systems are you analyzing, what functionality is included, are you including just one module or the entire application. For example, if you are analyzing a library management system, is your scope limited to just book borrowing model or does it include inventory, member records, fines and reports? This step ensures that we are only measuring what relevant and avoids any unnecessary complexity later on. Step 2 is to classify the components of the system. There are 5 steps. Let's break them down with quick example. External input EI and data entered by the user. For example, a form to add new book. External output. Data that comes out like a printed report to overdue books. External inquiries. Search or queries like looking up available book. No data is updated, just retrieved. Internal logical files. Database the system maintains like a file of a student records. External interface files. Database maintained by other systems but used by your applications. Thinking of it like accessing a central student information system managed by another department. Getting this classification right is super important because it drives the entire complexity and estimation process. Now that we have classified everything, we determine how complex each function is. Each component is categorized as simple, average, complex. The criteria of this includes number of data elements involved, number of files referenced. So a form with just 2 fields is simple, but one with 10 fields and validation might be complex. Why does this matters? Because it affects the weight we assign next. Here we assign numerical weights based on type and complexity. There is standardized table. For instance, a simple external input is worth 3 points, an average one is 4 points, a complex one is 6 points. Each component type has its own weight set. Once we apply this, we sum it all up to get the unadjusted function point count, which is a baseline measure of functional size. From there, you can apply adjustment factors for things like performance or usability if needed. Now let's highlight some of the advantages of FPA. Early estimation. You can estimate efforts even before development starts. Comparison. You can benchmark productivity across teams or projects using consistent metrics. Client communication. Clients understand functional features better than lines of code. FPA help bridge that communication gap. Productivity tracking. You can track how many function points are delivered per developer per month, giving valuable insights into efficiency. In short, FPA makes planning and monitoring much more data driven. Of course, there are some downsides too. First, FPA requires experience and training. Two analysts could give different estimates if they don't follow strict guidelines. Second, it's time consuming, especially for large systems. And third, it's not great for measuring algorithm complexity. So, if your software is more about heavy computations than user interaction, FPA might only fully reflect not fully reflect the efforts required. So while it's great for business apps and user facing systems, it may not suit all types of projects. So where is FPA used? Software estimation. You can estimate cost and timeline before coding starts. Outsourcing contracts. FPA is used to determine deliverable clearly. Performance measurement. Companies track how many function points team deliver each sprint or release. Change impact analysis. Adding a new feature, you can measure the increase in function point analysis and adjust the budget accordingly. It's especially popular in large enterprise and government projects. Sum up. Function point analysis is a fantastic method of measuring software functionalities, helping project manager and developers make better, more informed decisions. It's structured and objective and widely used in the industry. And mastering it can give you a real edge whether you are a student or a professional. Thank you all for taking the time to watch this presentation on functional point analysis. I hope it gave you a clear understanding of the topic and its importance in software project management. If you have any question, feedback, or just want to discuss the topic further, feel free to reach out. I truly appreciate your attention and interest. Thank you once again. Catch you in next one. Thank you. Thank you.